Yes, thank you. So, in Ukrainian pronunciation, my name is Denis, and I'm glad to present you the said topic, building reliable Python microservices, lessons learned from production downtimes. And where did I learn all those lessons, and where did I commit production downtimes? In Ukrainian called Reface. It's a multi-product company which builds machine learning-based applications to entertain people with head office in the Ukrainian capital, Kyiv City. And just to name a few, we have an original face application app that enables you to replace or place your face on pictures or videos with other people. We have an application to make your face sing songs, and we have, for example, an application Restyle, which enables you to restyle your photo or video. And we need many components to run this infrastructure. For example, we need the face detector for face detection, we need not safe for work detector to indicate if someone uploads not safe content. We need video decoding, video encoding infrastructure, and we physically just cannot put all those components into a single deployment. So we have the only one choice left. We build some sort of microservice architecture with when each service does its own thing, its own part of the job, and with some complex communication between them. And there is a good abbreviation for microservices architecture. It looks like this and means what could go wrong. So, what could go wrong with microservices? I think this slide like answers this question. This is my life. Today I want to share some small tips that I learned that helped me to fix our production. They are not like on the level of architecture or something complicated, just small tips for Friday evening. So we have microservices, we have communication. So the first question, what could go wrong with simple HTTP requests between our services? So let's define our toy application architecture for today. Let's say we build some social media, social network for animals. We have some users, we have our mobile application, we have some our backend API for this mobile application, and we have, for example, two services, dog detector and cat detector. And those services are, let's say, machine learning based. They receive images, they receive photos, and return score from 0 to 1 if we have a cat or a dog in our photos. So let's say on backend API, which is written using, let's say, fast API as a backend framework, we have some function, we have some endpoint to add a new cat into our system, and let's say we want to check if we actually have a cat on a photo, in a photo. And the implementation of this function, check is cat, can be quite simple. We just use IO HTTP, client HTTP library for async.io, and we make a request to our microservice and get a score. And if the score is above 0.5, we consider that we have a cat on a photo. And first thing that I'd like to address that is missing here is timeout. Why do we need timeout? What could go wrong without timeout for our request? Let's say attention span of our user is 20 seconds. 20 seconds, user will not wait more than this time to upload a photo of a cat. Let's say our mobile team, our developer of our mobile application made a 30 seconds timeout for request for backend API, and our backend API doesn't have any timeout for cat detector, and default timeout for iOS HTTP client for HTTP requests is 5 minutes. So what will happen? We will have this endpoint handler got stuck in our backend API, and the timeout of our mobile application will hit first, and we can go on a wrong path or fix our issue, because we may think that something is wrong with our backend API, but actually something is wrong with our cat detector. Okay, we defined our timeout here, but what value should we use? I'd say that the rule of thumb here is that we need to use the smaller the deeper we have our component in layers of our architecture, the smaller timeout we should have. Because our timeout B from mobile application to backend API should accommodate the worst case scenario when we almost hit timeouts on the side from backend API to cat detector. So we might want to set timeout B greater than timeout C on the picture. But what if we just have some connectivity issue? A connectivity issue to our cat detector. It can be some network issue, it can be zero downtime deployment that became non-zero downtime deployment or something like this. And 1 per 1,000 requests may fail. What we as humans do in such cases? We try one more time. So we as software engineers, we also can try one more time. And there is an awesome library for this called Tenacity. And it works as a decorator. We just put this decorator on our function. And this decorator will call this function more and more and more unless it works without raising an exception. But what if we have, I don't know, some syntax error in this code or something like that? We just got infinite loop. So to address this infinite loop, we need to define some parameters for our tenacity. And the two main things that we need to define, two main limitations are time and condition when we retry, when we need to retry. So from time perspective, we need to define two limitations. We need to define a general amount of tries or retries that we need to perform. On the slide we have five tries, but each try can take a long time to complete, 5 seconds, 10 seconds. So the second limitation that we want to set is general delay, that is 30 seconds here on the slide. So we limit our general execution time to 30 seconds. And we have certain behavior when we don't have availability of our cat's detector. We know that our function will take at max 30 seconds to complete. We have some predictability this way. Another thing is that we need to specify a list of exceptions when we don't retry and when we do retry. Because if we, for example, get a general HTTP exception, let's say bad request or unprocessable entity, there is no need to retry such a function, because if we retry unprocessable entity, we always will get unprocessable entity. Retries will not fix our validation behavior, right? And for example, here I defined a specific exception for retries, which I raise when we have server unavailable issue. But what if we do, for example, write one function for multiple requests? In this case, if we set a retry on this function, we can observe a very complicated behavior. Let's say we have our dog detector that works fine, and after that we have a request to our cat detector, which is not fine, which is unsuccessful. Actually, we can in metrics observe something like this. I will explain this plot. Let's say we have our green line that indicates successful requests to cat detector. And at some point we start to observe fails, and what we do retries as we specified in our code. And retries will retry more and more. They will call this function more and more, and finally we can have more requests to cat detector than we had before the issue. And for example, if our cat detector fails because of high traffic or high CPU load or something like that, by having retries, we make this issue worse. And also we increase traffic to our another microservice. We increase traffic to dogs detector because they are in the same function that retries. We can go even more with those calculations. Let's say we have some issues with cat detector. So we defined in our backend API that we do 5 retries before we fail. What if our mobile application team, mobile application developers set 3 tries to our backend API before it shows an error on mobile application interface? And what if user tries second time when they see an error in mobile application? In this way, we in theory, can go from one request to cat detector to 30 requests to cat detector. And it can be really hard to recover from this type of issues. And the takeaway from here is that you probably don't always need a retry, or you need to specify them only in one place of your architecture. What could go wrong with testing HTTP requests, with testing integration? The most straightforward approach is to mock our requests, to mock our responses. As we can see on the slide, with the help of a special library for mocking IO HTTP client library, we mock our external call to cat detector and define by code what payload response is supposed to be. And we test that our function is cat for such a score, for such a response, behaves in the way that we expect, that it returns true, which means we have a cat on a photo. But if we think about it more in detail, we may come to conclusion that what do we test here? We actually test here that our function works correctly with our mock, but not with cat's detector, right? And the cool thing to address these issues is that our mock can not represent an actual behavior of our external services. The cool library for this is VCRPy. We already had mention of this library right in this room today, and I will tell how it works in detail. We do our tests with where we call this function that makes a request to our external API, and VCRPy checks if we have any cached response from this microservice, from this external call. And if we don't have any cache, then VCR allows your client HTTP library to perform a real HTTP call. And after this, creates a cache file for request-response pair. And you can commit, you are expected, even more, you are expected to commit this cache file. And when you run your CI or when you run tests one more time, you have your request mocked. And the real HTTP request doesn't happen. And how it looks generally like this. You import our VCR library. You use it as a decorator for your test. This library already does all the monkey patching for all the popular HTTP clients. And when you run this test for the first time, it does a real request. When you perform it second time, it used cached request-response pair. And in this way, despite you have it as a unit test, but it becomes something between unit test and integration test. You use mock, but at the same time you did make sure that your code actually works with an actual service because your mock for this test is generated from a real request. And when you believe that this cache is outdated, that some changes could appear for cat detector, then you can just delete the cache and run this test one more time to generate a new cache. And in this way you make sure that your tests, that your integration is up to date. And here is just an example how this cache file may look. I'd say it's semi-human readable as any other YAML file. Sorry for that. And that's it with VCR. What could go wrong with health checks? Health checks are a thing that you may add to your backend application, and usually it's an endpoint that helps some external software to understand that your backend is up and running and is, let's say, healthy. For example, Kubernetes, Cloud, Docker. I don't even know how to describe Kubernetes. Sorry. How does it use health checks? For example, your app starts in Kubernetes, and Kubernetes has two types of probes. It has liveness probes and readiness probes. And you define in your configuration the frequency of those requests, timeout, what is the endpoint for readiness probe, what is the endpoint for liveness probe. 99% of people that I know, they use just health check endpoint for both readiness and liveness probe. And what it does, it starts to ping this endpoint with requests as defined in your configuration. When requests become successful, that it means that your application is healthy, and Kubernetes can start route external requests to this particular replica of your application, of your service. And when health check endpoint stops working in your service, then after a certain amount of probes, your application is declared as unhealthy. And Kubernetes does its thing to reboot your application, to not route traffic to this particular replica of your application. And the question is, what we really supposed to write in terms of code into this health check endpoint? And me and most of my friends, they do just this, like they define an empty endpoint that returns just status awk, HTTP awk, and call it a day. And it does work because this health check it indicates that your HTTP server that is up and running, that it's able to receive requests and responds to them. It's already pretty good, but a lot of articles on the question how to make good health checks. In these articles you may find that good health check supposed to make a request or make some pings to all the external dependencies of your particular service, like to other microservices or to your database or to Redis, or check status of your, I don't know, connectivity to some other third-party integration. And it's fine, but let's see once again at our toy application architecture. In case if we have a health check that checks health of our cat detector application. What happens when our cat detector doesn't work? We have failed health checks for our backend API. But our backend API as a service, basically, is fine. It works, right? It's not its issue. Our issue is within like cat detector deployment. And our dog detector is still fine, and our endpoints that are not related to cat detector are still working. Moreover, in this case, Kubernetes will start to reboot your backend API because health checks are not passing, and it can cause like a cascade failure of the whole your infrastructure, because all the services will be in some reboot loops. HPAs can get the wrong data for scaling, so your replicas, your horizontal scaling can go down, and when you fix cat detector, you probably may wait for a long time before your infrastructure comes back fully into a healthy state, because your cat detector should fully recover, your backend API should fully recover, all the replicas should be restarted, and all the replicas should respond with status HTTP OK on health checks. One more thing that can happen with your Python application is memory leaks. And what is memory leaks? Memory leaks is basically when you observe an increase of consumption of memory by your application over the time. And at some point, your application can hit a hard limit. Can hit a hard limit for memory consumption. And in this case, you may see an error called OM-kill, and it basically means that operation system, in order to avoid crash of the operation system itself, decided to kill your application that tries to allocate memory that is not available. It's definitely not a graceful shutdown, because your requests that are in progress, they will be interrupted like mid-air, your work will not be saved, and if you don't have some unit of work transaction style of functions that work with database, you may get an inconsistent state in your database. And what we probably could do, we could somehow, right from our service, from inside, measure its memory consumption and make a graceful shutdown, a graceful restart before we hit this hard limit. And we can achieve this with health check. And I did this, my friends did this, so it works. we can define some limit, and we can use a library called passutil to get memory consumption of our process, of our Python interpreter. And when this memory consumption is too high, we just can start return error from our health check, and Kubernetes orchestrator will just safely, gracefully restart this replica of our service. What could go wrong with not validating input data? Let's say we made a function, and this function is supposed to be used by other developers, maybe by other teams. We wrote type declarations for each parameter of this function. We have image URL as a string, we have target size of our thumbnail as integer, we have format as a string, and what this function does, it returns bytes of image that is smaller, that is resized to target size to have some small thumbnail on a website, for example. And someone who may use this function can think that format, for example, is not a JPEG or PNG. That format, for example, is HTTP header format, that like application JSON, image JPEG, image PNG, and end up with wrong usage of this function. Or set target size, for example, as too small or too high. And there is a thing, an approach called to avoid this is defensive programming. And defensive programming is a pretty wide thing, and probably it deserves like a separate talk for it. But for today's example, I can say that to make our functions, our code more in defensive programming style, we need to split them into like 3 steps. First step is to get our data, try to convert its type, and validate it. Strictly validate. Then we perform our main logic, and then we do all the error handling that we can. We recover from all the errors that we can, and we log all the errors that we can. Like this. And there is a great library that can help us with validation and data conversion stage called Pydantic. Do you hear me? Yeah. Pydantic is a validation library that is heavily used in fast API web framework. You probably already saw this library in action. And with this library, we can define in a style like a data class, maybe. We can define a class, a model, for some of our domain in our application. For example, image that is supposed to become a thumbnail, a smaller image. We can define a domain, a class for that, and we not just define data types like string, like integer, or something like that. We define a very particular types like HTTP URL, or we say that our target size is not just int, that it's int that is greater or equal than 64 or less or equal than 512. And how do we use it? We can just accept this domain as an input for our function. And when we use this function, we fill data for this domain, and we pass this domain object. And this approach plays pretty well with architecture called hexagonal. We had probably 3 or 4 mentions of this approach today or yesterday on this conference, and Pydantic is pretty convenient for hexagonal architecture because you can validate your data on every step, on every layer, let's say, of your onion of this architecture. Also, Pydantic provides us with a more convenient API for validation functions input, but this API is still in beta, and I know that Pydantic version 2 is coming probably maybe in a week, in 2 weeks, and this API is in beta now and can change, but it's a great thing that it exists. I decided to show it. Other thing that already was mentioned on this conference is the 12-factor applications. And what it is, as has been already said, 12-factor application is a collection of best practices to make your application more convenient for development and make it more like cloud native. And today let's focus on the third part, on the third factor, which is called config. And in config, they state that our application in different environments, in different deployments, on local host, on test, on stage, on production, must has the same code base, but must be configured only by environment variables. And Pydantic has a really convenient class called base settings, and you can define configuration for your application using those base settings. And this config fills its values from environment variables when they're available. For example, here I defined our configuration. I said cat detector URL, I said cat detector timeout, retries, threshold, all the things that must be, in my opinion, configurable for our application. And one of the best things with configuring applications through environment variables is that your operation teams or developers from other teams can change settings of your application without knowing your code base, without calling you. And it can be pretty helpful when your production dies in the middle of the night, and operations team maybe can indicate what is the issue. Maybe they need to fix some URL, and they don't need to go into your code base to figure out how it works. They can just change the value of environment variable. And another thing that I did in this example, which is, I sometimes do, sometimes I don't do, I set default values that definitely will not pass validation. And I did it in order to force myself or other developers to set explicit values for each of these configuration settings in order to have all our settings set in production explicitly, without some defaults that can be okay for local usage and not okay for production usage. And this is how our configuration can look like in a style of environment variables. We can define them in a .env file for local development. We can define them in CI. We can define them, for example, in Kubernetes deployment. In our example of application settings with Pydantic, I specified also a prefix for all our environment variables. As you can see, class config and prefix up name. And all our environment variables, they have this prefix. is just in order to be 100% sure that we avoid some mistakes related to that. We use a name of configuration that has environment variable already exist somewhere in our environment, to make configuration of our application in environment variables fully separable from all other things. What could go wrong without observability? Let's say, what is observability? Observability is our ability to know internal state of our application, of our infrastructure, from data that this application exposes. And by data, we usually mean logs, metrics, and traces. Everybody knows what is logs. Logs is a text that our application writes somewhere, for example, in std_out. They must be structured. And I suggest you to use JSON structured logs. So this way, when you use some software to navigate your logs, you can find something particular more easily. You easily can write query for your logs. And your logs should look like events stream, like user created an account, user uploaded a photo, you did encoding, decoding of video, something like that. So your logs contain only the data that you need in a way that you can recover what actually happened in your infrastructure. Metrics, they should be descriptive. You should use the right type of metric. For example, if we talk about Prometheus metrics, you may have, for example, average response time metric from your application, from your server. But average response time is not enough because it tells you only about an average response time, and you will not get the data about like how many requests do you have which exceeds 10 seconds for response time. You will not get this data from average. You will get this data only from quantiles, from percentiles, so your metrics must be precise. And you, in my opinion, should collect business logic numbers in metrics. What does it mean? For example, for our toy application, where we have an endpoint to upload images and then recognize if you have a cat there, I would put to metrics, for example, size of our image or average score from our cat detector. In this way, if I see abrupt change in average image size, I can think that probably mobile developers think probably our mobile application somehow changed, that it started to upload smaller images or bigger images, and it can impact our performance of application. I mean performance in sort of business metrics, like satisfaction of our users. And I can go and address this issue. And traces. Traces, I will show you what it is, but it's a thing where we can like track how much time did we spend on each stage of our architecture, and even maybe for each function in each service of our application. And they must exist on every level of our architecture, so we can see the whole path that our request makes, and we must be able to tell from our traces what actually happened, like describe execution path. I'm sorry. And all those three things must be easily accessible. They must be on your fingertips, so you can like find them and use them pretty easy, pretty fast. Because if you have a production downtime in night, you don't want to call some weird comments in your terminal. And cool project that tries to have logs, metrics, and traces together is OpenTelemetry. It also already was mentioned today. It's a standard API, SDK, and tools to make logs, metrics, and traces standardized across all languages, across all platforms. Status for Python implementation, I'd say, is still under construction, but I already use traces from OpenTelemetry, and this is how traces for our application may look like. For example, you can see that we have. Can I make it here? Can I make it later? Yeah. You can see that we have request to our images and point to other image. We can see that we do IO-HTTP post request to our cat detector. We see the performance of our cat detector. We see when the processing started, when processing ended. We see some call of some function that saves data to the database. And as you can see, we see that we did an HTTP request, but somehow processing on this request started after some time, after 300 milliseconds, and we see an issue that we can start to debug, start to address. So we maybe need to look into our Nginx configuration or something like that to figure out the source of this performance problem, the source of this issue. And I'm out of time, unfortunately, so this QR code is linked to GIST or GIST, I'm not sure what is the pronunciation here, with my LinkedIn profile, with our web version of our application interface. You may also find our repository for Python summary metrics that supports quantiles. And all the notions and libraries that I mentioned today, they are in this GIST, under this QR code. Thank you. Let's go to question section. Why not rely on Kubernetes memory limits? Because when you hit a limit on Kubernetes, usually end up having out-of-bounds memory error, and your application will be killed without any graceful shutdown. That's from my experience and experience of my friends. Why did you set the database?
Why did you set incorrect?
Yeah, why?
By database settings, not setting any default value will generate validation error.
Well, because I wanted my settings to not initialize until I explicitly set all the settings, and
So I can make follow-up on that, because Pydantic heavily uses aggregates to determine what kind of fields are required and which of them are not. If you declare something as str instead of optional str or str or none, it's going to complain if that value is not given during the initialization. So you don't have to actually put some dummy default values in order to enforce people to explicitly give that value as a configuration. And this is what I think, and I tested that. Current version of Pydantic, and this is how it works.
Current version of Pydantic. Maybe I relied in my mind on some older versions because I didn't update it, and it's heavily under construction. I tested the code that was on slide. I ran it locally, got a validation error that I wanted, and was like.
I mean, your code works because if you set the value, the default value is going to be used, and it's going to complain that the value is incorrect. But if you don't assign the default value, it's still going to complain, but it's going to complain that the required value is not present.
I see what you're talking about. Yeah. This will work in a way maybe it's a mistake from my side. You're right. Apologies for that.
No worries.
Well, I think that's it. You can find me tomorrow, today, for any additional questions. Thank you.